In this tutorial, we will learn how to combine organic anatomical forms with engineered objects to simulate an operation. Specifically, we will capture data from a cervical spine CT to create a model of the first two vertebrae. Then we will isolate the C2 vertebra and simulate a fracture. Then we will determine what the optimal specs would be for screws that would transfix this fracture. Using the steps in Lesson 3 of CAD for Physicians, we import the cervical spine CT into Slicer, 3D Slicer. Then we load that volume onto Slicer. Then we go to the volume rendering module, enable cropping, and display region of interest. Then we select the preset threshold for bone CT. And we adjust the manipulators to isolate the C1 and C2 vertebrae. Then we go to the crop volume module, select voxel-based cropping and crop the image. Then we'll save that image. The only file we're interested in saving is the subvolume NRRD file. Then we'll go to the Embody 3D website and we load our NRRD file onto the website. We enter a name for our file. And save it. 10 or 15 minutes later, we go back and download our STL file. Then we can either use that STL file to directly 3D print the object, or we can insert the STL file into Fusion 360. We edit the mesh body. The first thing we do is we change the visual style to shaded to get rid of the tiny millions of meshes on the surface. Then we change the appearance, select paint, a yellow paint, and then double click on the paint and change it to a light yellow. Next, we're going to use the plane cut menu in order to isolate the C2 vertebra and the odontoid process. Repeat that. Again, plane cut. It's set to trim. We flip it and adjust the manipulator and press OK. Alright, now we need to get rid of the posterior elements we just selected. We open the mesh palette and we expand the selection to the connected regions and delete it. So now we have the odontoid process, which is the portion of C2 vertebra, and a little bit of C1 in front of it. Now we're going to create an artificial fracture by, again, using the plane cut. This time we split the body using that function. And now that we have a fracture, we can paint the top half of C2 in a different color using a glass in order to see the screws. Now we're going to create a parametric screw. First we go to our sigma and specify some user-defined parameters that we'd like to change. The first is the diameter of the screw. We set the initial diameter to 3.5. The next is the length of the screw. We set that initially to be 30. And the thread length, we can set that initially to 15. Press OK. Now we'll draw our screw, create a circle. The diameter of the circle is our user-defined diameter. Stop the sketch, extrude that. The length of extrusion is the length of our screw, so we use that user-defined parameter. And then we want to create a leading point for it, so we just extrude that further 2 millimeters and extrusion angle of -30 to make it pointy, and do the opposite on the back end to create a screw head, 2 millimeters and +30 taper angle. So we have the body of our screw, and then we'll put threads on the screw. It will be a modeled thread, not full length. The thread length is the thread length that we specified as the user parameter. We change the type to a metric forming screw, and we set it to 1.6. Here's our screw. It's a lag screw. The threaded part of the screw should only go in the top part of the C2, which is fractured off. Let's change the color of the screw so we can see it better. We'll select titanium, and then we change the titanium color. Okay, now we're ready to do some surgical simulation. We're going to move our screw to where the typical entry point would be at the anterior inferior margin of C2 vertebral body. And we're going to angle it such that it points to the superior posterior aspect of the tip of the odontoid process. And we're going to center it. Press OK. Now we're going to see if that screw has sufficient length, which it doesn't. We want it to extend to the vicinity of the tip of the odontoid. So we open our parameters and we play around with the length. We're going to change that to 40 millimeters. That's a little too much. It's protruding through, so we reduce it to 38 millimeters. That's perfect. And we change our thread length to 20. That's still a little too shy of the full length of the fragment. 22 is right. So now we have one perfect screw. Let's see if we can fit in a second screw. So we move that first one, we copy move it, so it creates a new copy of the screw. Move that a couple of millimeters to the side, and we move the original a couple of millimeters to the other side. Okay, let's look at it. Seems a little tight. The screw is beginning to break through and the screw heads are overlapping. So let's reduce the diameter of our screw to 2.5. And that looks perfect. So we conclude that we can insert 2 screws into this odontoid fracture, measuring 2.5 millimeters in diameter, 38 millimeters in length, and with 22 millimeters of thread.